out like a cattle call and said, what are y'all interested in learning more about? And of the ones we got back, we didn't get back very many, but of the ones we got back, manipulative with fractions was the most common. So we're going to spend about the first hour on that before we go into the geometry piece of this, okay? Using manipulative with fractions. So you people, you math people who teach like 8th grade, okay? Be sure that you are asking questions and not telling people what to do, right? So, let's see here. And I'm supposed to shoot a monkey. Oh, it helps if I turn it on. There we go. So, just a reminder, in mathematics and science and probably everything else, but math is my specialty, so that's what I concentrate on. You should begin any new concept with the manipulatives. Any new concept should begin with the manipulatives. And then what do you go to, Tim?
Oh, pictorial.
A pictorial. Now don't skip that pictorial stage because that's a very important stage. And then what's the last stage you should reach? The abstract. Very nice. That was a choral response. My bad. So the reason the pictorial is so important is because it kind of gets them away from the concrete and prepares them for the abstract. And many teachers skip that altogether and they're doing a disservice to their students. And on the STAR test, they can draw pictures if they need to help them, okay? So we're going to talk about fractions. Fractions can be taught using a variety of manipulatives. There's the area model, which we're going to do today with the pattern blocks. There's the linear model, which we're also going to do with the Cuisenaire rods. And those are my Cuisenaire rods because I didn't tell the girls to tell y'all to bring yours. So be sure they all get back in my my box. And then there's the set model. But for the elementary teachers in here, set model can only be taught after the kid has conservation of number. I'm winded today. I'm so out of shape. Conservation of number. So what is conservation of number? Raise your hand. Laura, do you know? It's really a Pt.2 concept, conservation of number.
Understanding what the number actually is?
Yes, sort of.
Two objects or?
Well, that's really cardinality. Conservation of number is, I've seen my own grandchildren do that. If they have like a set of blocks and they're all close together and there's like 5 of them and they know there's 5, then if you spread them out, they sometimes think it's more until they have conservation of number. So they have to realize that just because things are spread out and the area it's covered is larger, it's still the same number of objects. Conservation of number. So you can't use the set model until they have that conservation of number, which is about 5 years old, 6 years old. So all of your students should have it. Yes, ma'am.
How do you overcome if they don't have that conservation of numbers? Because I have some 5th graders who don't have that. How do you work on bridging that gap to where they do have it?
Well, you're going to have to give them the manipulatives and have them just practice, you know, counting the set close together and then spreading them out in the one-to-one correspondence. Because part of the conservation of number is one-to-one correspondence. If they don't realize that this is 1, 2, 3, 4, pretend I'm touching those,
Yes.
and then I move this one way over here, it's still 1, 2, 3, 4.
So you would move to something more solid as this, because I tried doing it with like, you measured out half a cup and then we poured it into something else, and they could not realize that that was,
Having
you
to
needed to do this
Yeah.
repeatedly.
Yeah, repeatedly, like many, many, many times. It's a gradual thing. They'll get it.
Okay.
You won't really notice when they get it because they'll just get it. Yes,
Okay.
ma'am.
In science, the American Association for the Advancement of Science says that students need to experience the concept hands-on labs, as we typically call them, 4 to 5 times, the same concept. So you can't have one lab per chapter, like you typically see in textbooks.
Or one activity per concept.
Yes.
Okay, so that's why we're going to use the pattern blocks and the Cuisenaire rods with our fractions today. So, one important concept, and I'm not going to deal with addition and subtraction of fractions because they seem to get that. I'm going to deal with multiplication and division. So one important concept is understanding one, and is your answer going to be more than 1 or less than 1, or more than the number you started with? or less than the number you started with, okay? So here, we have 1 times 3/4. 1 times 3/4. Jen, take that, Jen.
This
What does that mean?
it means that you are going to multiply 3/4 of something by 1, or 1 of something by a number that is less than 1.
Okay, so I'm multiplying 1 by a number that's less than 1. So will this answer be 1, greater than 1, or less than 1? Denise?
It's gonna be less than,
And why?
because any number times 1 is that number, and 3/4 is less than 1, so therefore 3/4 is gonna be less than.
Okay, what property did she just use? Raise your hand, please. What property did she just use? Brenda, do you know it? Identity, multiplicative identity, very good. That's not what most of my students say. They don't think of the multiplicative identity at all. What do most of my method students say when I do this with them? What do you think? Now, don't speak out, remember I'm old, so you have to raise your hand, or I have to call on you. What do you think they say? They're not used to using manipulatives. They're used to being taught stand and deliver. What do you think they say?
No, I just asked a question.
Okay, don't ask yet. So what do you think they
Well,
say?
look, I can't think what they say because they're all the different answers, all the different methods, yeah. So if I can listen to different methods as a refresher, that would help me answer the question.
Okay, just pretend that you had a teacher that just told you the algorithm for this and didn't explain anything about why it worked.
Okay.
Okay, just memorize the algorithm, don't ask me why it works or how it works. Melissa, what do you think they say? You being science, I'm sure you know.
Technically, I taught math, so I don't think I should be able to answer, right? I would have just said because, well, what Denise said, because it's multiplied by 1, anything multiplied by 1 is itself.
Okay, all right.
But I wouldn't have known it was the identity property. I
Yes,
just
it's
know
the multiplicative
the
identity.
multiplication facts,
Yeah.
anything times 1 is itself.
Yeah, all right. Most of them convert this to of,
Decimal.
not a decimal, to the word of. 3/4 of 1 is 3/4. Because they've been taught that when it's multiplication, it's of, that means of, which may or may not be true.
Is that like in the younger grades?
Yeah, this is
Okay, I've never.
5th grade, 6th grade. So how about this one, this Jen? More than 1 or less than 1? Because,
Because 5/4 is greater than 1.
and you're multiplying by
Multiplying by
the identity.
yes,
All right.
sorry.
So here, if we have 2/3 times 3/4, 2/3 times 3/4, is the answer going to be more than 2/3, forget that first part, more than 2/3 or less than 2/3? Toby?
I want to say it's going to be more than 2/3.
And why?
Because 2/3 of 3/4, I'm changing it to a decimal. And I'm working-
Toby is science, so that's normal for them to change it to decimals.
And that 2/3 of 7,500 would still be more than 6,600.
He said something interesting. He said 2/3 of 7,500. What's 1/3 of 7,500? In your head. 1/3 of 7,500. Yeah.
2,500?
2,500. And we have 2/3 of them. So we have how much?
50.
50 hundredths. We have 1/2, right? So is that more than 2/3 or less than 2/3? Less than 2/3. Because we're multiplying by something less than 1. We want less than 1 whole of this. Right? Okay. So, in this one, yes, ma'am.
There's just making that connection, you know, when you teach whole numbers and multiplication, because they, when you multiply, things get bigger, and then with that answer, our answer actually got, which is like mine.
Yeah, it's, yeah, yeah. So thank you for bringing that up. Did y'all hear what she said? Would you say it really loudly?
When we're teaching kids multiplication with whole numbers, their answer, they know that it's always getting bigger. So when you start multiplying
Back
by,
up. You said they know it's always getting bigger. They have been told that the answer is always bigger, which is incorrect later. Go ahead.
so when we're multiplying by fractions, them actually realizing that it's a smaller number is just beyond their comprehension at that point.
Right. Now, she teaches second grade, but she taught fifth grade last year, so she knows, all
In
of
fifth
this.
grade, yes, that was.
So here, we're multiplying by a number less than 1. So would our answer be more than 3 1/2 or less than 3 1/2? Denise?
I think it's gonna be less.
Less than 3 1/2. Why?
Because you're multiplying by a smaller number,
Okay.
so it's not a whole.
Okay. Cody?
Looking back at the previous problem and then looking at this, I would want to put the fraction before the the 2/5 before the 3 1/2.
And what property lets us do that?
I want to say the associative, no,
Commutative.
commutative, okay.
So he's switching it in his head. 2/5 times 3 1/2, and that's legal because that's commutative property.
So you're only getting 2/5 of 3 1/2, and it would be less than that, or that's what I want to say.
Okay, so he went back to the word of. Okay, so he would get 2/5 of 3 1/2. Yes, ma'am.
And it just hit me too with the 1 times 3/4. When it's times 1, it stays the same, the identity
Yeah.
property.
Multiplicative
So if
identity.
anything's less than 1, it will be less than that
Yes.
number.
So if you're multiplying the 1 by something less than 1, is that what you're talking
Or
about?
3/4, it's the same because it's by 1. So if I'm multiplying 3/4 by something smaller than 1, it's gotta be smaller.
Less than what you started with.
Right.
Less than what you started with, which is not the identity, really. You just know it's gonna be less than what you started with, because you're getting 3/4 of what you started with. This just happened to be also the identity, Jen.
So I know that, I'm about to go back into this with my students. We have them use things and actually multiply things out and break it into pieces, but when we go back into reteaching, I teach it as if we're multiplying by a number less than 1, you're always gonna have a number that is less than what you started with. Is it bad to say that now? We did it when we did rational numbers at the very beginning of the year, but they still have that lack of concept of it's less than 1.
Yeah. They should discover that through your lessons,
Okay.
but if you're like 2 weeks before the STAR exam, then you may.
Which we are.
You have to say it.
Yeah.
Not that it'll stick, because
But I mean, you did it
telling is
already.
not teaching.
Okay.
So they just need lots of, as Dr. West said, they need, 3, 4, 5 experiences with it before it's really gonna go into their head. Okay?
Dr. Browning,
Yes.
we were in one of the exemplary math teachers that has been in mix, and we were observing actually a review, and so she had stations that kids could rotate among. And at the last minute, she threw out the manipulatives, and she was surprised at how many of the students went back to the manipulatives first voluntarily. She didn't direct them or anything. And so I don't know how that plays out with reviews. Dr. Browning, you want to comment on that?
Well, you should always have them available. Of course, it's not available on the STAR exam, which is why the pictorial stage is so crucial here. But if you have them available, and then you also make them draw it, then, you're getting somewhere with them. So, yes. Okay, so division. Division is something that people just don't understand why and how it works. When I was, taught to divide, I was taught this little sing-song thing. How do you divide fractions? Y'all know the song?
Not the
Jen?
I don't know the song, I know the rule, and write the second fraction, multiply.
It's not really a song, it's kind of a poem. Anybody know the poem that I was taught?
Nobody nice to know them. I was gonna say,
It was, we're dividing fractions, don't ask why, just put the second number and multiply. And that don't ask why, don't write that down.
it might stick in my kid's head.
Do not teach that, please don't teach that. Unless you're a week before STAR, which we are. And don't ask why it bothers me, because I was somebody that had to know why, or I could not remember it. Like the lattice multiplication, I cannot remember that because I cannot figure it out. Every time somebody shows me how it works, I understand it. And then the next day after I've slept, I don't have it. I know it works with some kids, doesn't work with me. All right, so here, I had, my teacher also told me one time that I didn't know my tudums. So I went home and asked my mother what are tudums, and she didn't have a clue. My mother taught math. So then I went back to school and I said, Miss Young, I don't know what a tudum is. Could you please tell me what a tudum is? She said, you know, tudum's 1, tudum's 2. Yeah.
Like a gazenta.
Yeah. So, and then I had the guy that told me gazentas. He said, you know, this gazentas. And I was like, what's a gazenta? He said, you know, goes into. Okay, I had some really weird teachers. You know, they just weren't trained. It's really not their fault.
They were from East Texas.
They were from East
Texas.
They were from East Texas. Okay, so here we have 6 divided by 1/2. That really means how many 1/2 are in 6, which is what, Johnny?
Oh, but how many 1/2 more than 6?
How many 1/2 are in 6?
12. Wait. Yeah.
She says 12. Raise your hand if you agree. Okay. Raise your hand if you think it's 3.
Uh-oh.
It is 12. Okay, it is 12. And if you think of money, you would be on the right track. If you have $6, how many half dollars would you have? You would have 12 half dollars. There are 12 1/2 in 6. So here, 1/2 divided by 3/2 means how many 3/2 are in 1/2? Let me ask a question. Is a whole 3/2 in 1/2?
Can we both stop the manipulative?
Yeah, I need a plate.
Okay, hang on, let's think for a while. Is a whole 3/2 in 1/2? Can I, which of these is larger? 3/2. So will 3/2 go into 1/2?
No.
You have to be a fraction number, right?
Yeah.
Okay. So I know that you can flip the second number and multiply in your head, right? But we're not going to do that. We're going to do it with pattern blocks. So here is the model for this problem. Using your pattern blocks with the hexagon as the whole, okay? The trapezoid would be 1/2. I'm going to give you a few seconds to open your pattern block.
Once I saw the picture, I was like, oh, that makes sense.
Yeah, 2
So basically, put this is when I wrote the 1/2. I'm saying I would take this.
Look at 1/2 divided by 3/2.
Go into
Okay, we can come back together.
Put two together.
We can come back together. That means I get to talk and y'all don't. Okay, so if the hexagon is your one whole, your trapezoid would be 1/2. Okay, so this is modeling 1/2 divided by 1 and 1/2, which is the 3/2. Correct? Okay, so will 1 and 1/2 or 3/2 go into 1/2 a whole number of times? No, so it's going to be a fractional answer. So then it's not really a gazenta problem. It's not really a gazenta problem. It's really a how much of this is here. How much of this is here? So you have your pattern blocks out. So tell me, when I ask you to, not right this minute, how much of this expression is here? Remember, you're a math teacher, and you know the answer. You can only ask questions, okay? And please, science people, don't convert it to a decimal. Okay? Shucks.
How much of this is in there?
That's why we do it like that.
Because I've never worked with it. Okay.
Saying yes, you're right, or no, you're wrong.
Is that how you interpret? Because you're interpreting, so there's no, the question is.
Okay, let's go back together. Let's go back together, please, if I can have your attention. Margaret, who is science, has what she thinks is the answer. She's going to explain it to us.
Okay. Well, my answer was 1/3. Because if you just by looking, you can see that one of these is 1/3 of the whole total of this. This would be 1.5.
Yes. So one of these is 1/3 of the 3/2.
3/2, yes, 3/2.
So,
So 1/2 divided by 3/2 is 1/3.
yes, because, can you put that in a sentence?
Because 1/2 is 1/3 of 3/2.
She said 1/2 is 1/3 of 3/2, is that correct? Brenda, what do you think?
She said
1/2 is 1/3 of 3/2.
Well, you do have 3/2.
Yes,
So if you take one of those, then you have 1 out of the 3.
you do have 1 out of the 3, so she was so afraid to say that, but was she right?
Yes.
Yay! Yay, Margaret.
Did the
Okay.
teacher show any expression that would tell her she was right?
Or wrong?
I got
Or
no
wrong?
hints on that.
No hints at all. I don't, I work really hard at looking stupid. Really not that hard.
With this problem, I would want to put more pieces inside this and have the same pieces for this, or this,
Okay.
that would make that shape. And then remove the same number of pieces, and then see how many are left of those pieces in this.
Okay, so he wants to convert them all to the same block.
Size.
Either all trapezoids or all triangles. A lot of times the students will revert back to the triangles because they fit in all these pieces. So, and that makes perfect sense. That's one way to do it. Okay? Yes, ma'am.
But if you do it that way, then you're going to have to
Hang on, I
simplify.
cannot hear her.
You're gonna have to simplify an answer. I mean,
Yes.
so if they're doing it, if they're thinking that way on the STAR test, or drawing those kinds of pictures, they have to understand that they're going to have to simplify that answer, because that next step will be finding your answer choice when they're simplified.
Right, if you convert these to all those triangles, then you will have another step that you'll have to go through. Yes, that's two steps, converting at the beginning and converting at the end. Okay, yes ma'am.
If we have iPads and we have an app with these pattern blocks, is that considered manipulatives or not?
It's actually, it's pictorial. It's pictorial, but it's a step above pictorial, but not quite concrete. Kids need to, some kids, most boys especially in tactile kinesthetic learning, need to actually move the things with their hands. Yes ma'am.
I wonder if the children's set is actually like to start the kids out that way and telling them to find equal pieces, because then they can actually see that there's 3 of them now.
3 trapezoids.
Trapezoids. And if they only have the hexagon and maybe seeing, out of 2 pieces instead of the actual thirds. So I'm wondering if they would get confused.
What do y'all
If they
think?
didn't have 3 of the hexagons to see that it's a third.
So her comment is, would it be better to have them convert these to the same pieces, not the triangles though?
Right.
Just the trapezoids. Thoughts?
And then have them that are triangles?
No.
See,
Now, as long as all the pieces are the same, you don't have to go back to the triangles. Thoughts? Jen?
They have to have a really good understanding of equivalent fractions, but I think that would be, for a lot of kids, they'd see it more quickly, but they really have to understand this is this because,
Yeah.
and in 5th grade, they should, by then, understand equivalent fractions.
Yeah, they should know equivalent fractions by then. Depending on how it's taught, they may or may not be able to convert it to pattern blocks. Okay, so let's go back to the more than one, less than one concept. This is now division. So our multiplicative identity property is not going to apply because that's a multiplicative identity property, not a division identity property. So, will this answer be more than 1 or less than 1? Will 3/4 go into 1 at least 1 time? You see how when I rephrased that, the head started going up and down? Okay, Toby?
Do they still use remainder?
Yes, but we're not gonna deal with that today, I think it's out, so we'll deal with those next time. Well, actually, when you get your context problem in there. So 3/4 will go into 1 at least 1 time. So will this answer be more than 1 or less than 1? Okay, Margaret says more than 1, why?
Because 3/4 will go into 1 at least 1 time,
Okay,
and then some left over.
with some left over. So, you got a question?
How did you phrase that question again? How many, or how, you know, will 3/4?
Will 3/4
go
go into
into
1 at least 1 time? Thank you. You can write that down, but you can't write the whole thing.
I didn't write them.
Okay. How about this one? Greater than 1 or less than 1? I went back to multiplication here, don't let it fool you. Greater than 1 or less than 1? Greater than 1. How do you know? Who have I not picked on? No, I picked on Quentin. Here. Greater than 1 or less than 1?
And you can use where I go,
Yes.
because 5/4 is greater than 1.
Okay, and?
And using the identity property of multiplication, 1 times any number is that number.
So he went back to the multiplicative identity, which is fine, okay? So, how about this one? 2/3 divided by 3/4. Well, 3/4 go into 2/3 1 whole time.
Think about what she just said. Please stick on Melissa Dr. Brown.
No picking on your friends now, okay?
She needs understanding, she's not getting it.
You said I'm not allowed to convert into
Do
decimals.
not convert it to decimals, please.
I don't, okay.
Okay,
So then would I find the least common denominator and go from there, or how would I do it without converting into decimals?
you could find the least common denominator, that's a whole lot of work for,
Oh, but I'm trying to understand like how, because I automatically, and this is something I said to him, if it doesn't convert clean, I would have a more difficult time. You know, so like 6, 7, and then at that point, then I'm estimating 6, 7.
okay. So he's asking a really good question. He's science, remember, so he's trying to convert to decimals, okay? Which is larger, 2/3 or 3/4, Wendy?
3/4.
3/4. So will one whole 3/4 go into one whole?
No. But that's the thing is I converted into decimals, so I mean, I already know, but that's what I'm saying, if I'm not converting to decimals, then how am I supposed to, the only other method I can think of is to find the least common denominator, and that would be 12, and then go from there. I don't have another method besides those two.
Okay, so in whatever grade teaches division now, which I'm not quite sure what grade level that is, I think it may be fifth, division of fractions.
Oh.
Fifth.
Well, we don't do that. We don't
Yeah,
divide a
don't
fraction
divide
by a
by.
fraction.
Okay, so it's
That's a whole
6th or
nother-
7th, all right, so, let's think about this. Will your students know in 5th grade
I guess that's a good point too.
that 3/4 is greater than 2/3?
I mean, I should.
Yeah. 7th grade, 8th grade should. What if they don't? What are you going to do? You've got to give them the pattern blocks, they've got to use those time and time and time again so that they figure that out.
So when I thought about, like, also wanted to.
And let's listen, okay, one conversation at a time, and Margaret has the floor.
I just wanted to do the decimal, convert to the decimal, but then I thought, okay, wait, this is a whole. You split a whole into 3 parts, and then split a whole into 4 parts. Which one's gonna be bigger? 2 of the 3 parts or 3 of the 4 parts? And so just visually, it's like, oh yeah, 3 of the 4 parts.
So most kids revert back to
Put a
pizza.
picture,
And
like,
most
yeah.
teachers revert back to pizza. Would you rather have 3 out of 4 pieces or 2 out of 3 pieces of the same size pizza? The one piece that you don't get here, that 1/3, is going to be larger than the 1/4 that you don't get, so this is larger than that. Yes, sir?
Okay, on the, using these, I keep trying to grab hers, I got mine in my lap.
These.
Yeah.
It's okay, I'll get over it.
You would have a whole portion, like, maybe like these, make a hole, and you would take one out, or no, you'd have or let's say this made a hole and it was only 3 pieces.
So we're gonna walk through what Toby is saying. He said we have a hole, and he held up the blue,
Well, that
Parallelogram.
doesn't work with that one,
hold up make one hole with the blue parallelograms.
but, well, I'm gonna need.
Make one hole
Oh, there we
with the blue parallelogram. Remember, one hole is the hexagon.
Yeah, we got it.
Okay, hang on, let everybody get that made.
Now,
Okay. So how many blue parallelograms make one hole? 3. So remove whatever you need to remove to give you the 2/3 of the one hole. There you go. Now, Toby, how would you model the 3/4?
well, on that one, I would use the orange block. Yes, ma'am. And I could remove one block, and that would give me the 3 out of 4.
There's a problem using the squares for the 3/4 because you've changed the area. Unless the square is equal in area, unless the area of the square is equal to the area of the parallelogram. Can we decide if the area of the square is equal to the area of the parallelogram?
You could if you measured.
To what? Try to convert it to the triangle.
You used to use green.
They're called triangles, Toby. We're using the green triangles.
Well, and I
So what are we
And they're gonna be used to.
So how many green triangles, y'all listen to me? How many green triangles would make one blue parallel? A green parallelogram? Two? So how many green triangles make a square?
How many triangles is a square?
They don't? So we can't use that model? Actually, they do, but the kids won't see it. Okay, you have to cut up that triangle to do it.
Oh, yeah, that's, I was thinking about
The way they are
Yeah, the way they are now, the kids won't do it. So what Toby was trying to do, y'all listening? What Toby was trying to do, using the two blue parallelograms here for 2/3, and then 3 out of the 4 squares for 3/4, won't work because we're talking about 2 different homes, so 2 different homes. That's not going to work, okay? Okay, Toby? All right, so, I have lost my whole train of thought of where I was with this. So do we
How
have an
many
answer?
3/4 can fit into 2/3 kid first?
Okay, hang on. Yeah, the question is just, will 3/4 go into 2/3 more than one time or less than one time? We're not looking for an answer here. Less than one, Melissa, Jen says. You agree?
Yes.
Can you explain why? B?
Well, we converted the green triangles into 2/3, and we found that after we take one of the 4 triangles, 1/4 away, we were left with 3/4.
Okay.
And then visually, we're able to see, right here,
Okay. See what?
that 3/4 was less than 2/3.
Is it?
Wait. 3/4 is more than 2/3.
3/4 is more than 2/3. So we're dividing by a larger number. So will this go into the 2/3 one whole time? When we divide a larger number into a smaller number at least one whole time. No, so the answer to this is going to be a fraction. Okay, now in your head, I know you've all done it already. Flip that second number and multiply and tell me the answer. 8/9. Less than 1. Less than 1. Yes, ma'am.
So there's not a way to prove it with these blocks?
Yeah.
Not with the pattern blocks, which brings up a good point, thank you Toby for doing this. You have to make sure that the problems you give the kids fit the manipulatives that you have.
Yeah.
Now, I'm working with adults, I have a little more leeway here. There's not a way to back and forth with these problems. Now, you could use a color tile, or you could use, anything else that would work. I wouldn't use base 10 blocks because they're repeating 3. But color tiles would work, yes, sir.
If you were to put these on grid paper, and you, but you look at the area? Could you divide that area?
You could compare the areas,
Okay.
yes, yes.
Well, I mean, the 3/4 has a certain area, the 2/3 has a certain area, could you divide those areas?
You would compare them, because we only want to know
Oh, you just want to see whether it's greater than.
more than one or less than one. That's all we want to know. Yes, ma'am?
So we're using these. We have 1 whole, 1/2, 1/3, 1/6. We cannot use these. The square and your,
There is a relationship between the beige parallelogram and the square. I have forgotten what it is, but I rarely ever use the beige parallelogram.
you do use the orange square?
Occasionally, but not with the triangle. Okay, yes, ma'am. Yes, ma'am.
When I'm teaching the fractions, I have the kids try it with the common denominator. And because some of them see it easier with 8/12 divided by 9/12 is 8 divided by 9, so 8/9. And some of them do not understand the multiplicative
Yeah.
inverse and all that
Yeah.
stuff. They're like, what? But if you tell them to do the common denominator, then it makes a little more sense.
Yeah, and that's true. Did y'all hear what she said? She does have some of her kids, or allow some of her kids, maybe I should say, to get a common denominator for these things because they could see that this is 8/12, and this is 9/12, and so that answer's gonna be less than one. It's still abstract. It's still very abstract, so you still haven't used the concrete or the pictorial yet, okay? All right, so this one, we just want to know if it's more than one or less than one. 3/4 divided by 7/3. More than one or less than one? Have I picked on Denise yet? No. Huh? Have I picked on you yet?
Yes, I believe you have.
Several times.
Did I pick on Laura?
No.
Okay, Laura, which one's larger, 3/4 or 7/3?
7/3.
Good. So will this answer be more than one or less than one? Will 7/3 go into 3/4 at least one time? No. And how do you know that?
Because if 7/3 is bigger, larger than 3/4, you just can't put it in.
Right. It's too much. It's too much. Yay. Right.
Can a student just say, well, it's an improper fraction, and the other one's just a fraction?
Yeah. So since this is improper, it's automatically larger than a proper fraction. So it's less than one. It won't go in one whole time. Did you still have a question? All right. Okay. So just a few more. Will the answer to this be more or less than the first number? 3.5 divided by 2/5. How many times will 2/5 gazenta? 3.5. More than 3.5 times? Fewer than 3.5 times. You got an educated guess? I don't want the answer, I just want to know if it is, the answer is more than 3.5 or less than 3.5? What do you think? It will be more than. More than 3.5 times? How do you, what makes you think that?
Because kind of rounded, but I know I have 3 holes. So 2/5 is less than a hole. So 2/5 can definitely go in more than 3 times.
So 2/5 is going to go into 3 more than 3 times, right? So she thinks that the answer to this is going to be greater than 3 1/2. Greater than 3 1/2. Raise your hand if you agree. Okay, raise your hand if you disagree. raise your hand if you didn't raise your hand. Why did you not raise your hand? Toby,
I still don't understand what she just explained.
you want to explain it again?
Yes, so I didn't use any things, specific as far as decimals or, I know my first number is 3 wholes.
Okay.
So I mean, you can, if you wanna use the hexagons as, pictorial, and I have 3 hexagons. Well, 2/5 is less than a whole,
Right.
okay? So, I don't wanna get off track, but if it's less than a whole, I know I can fit that into my 3 hexagons at least 3 times.
Okay.
Okay.
At least 3 times, but since it's less than a whole, I know it can go more,
More than 3 times.
more than 3 times.
So the answer here would be what, Toby? More than 3.5 or less than 3.5?
It can go into it,
Goes into.
more,
More than 3.5.
yes.
Good. Okay. So Johnny, you didn't raise your hand either. You got it now?
Yes.
Okay. All right. This one, 3.5 divided by 7/5. Will the answer be more than 3.5 or less than 3.5?
More than the dividend or less than the dividend? Would you use the word dividend there ever?
I don't with my methods people. I didn't with the kids that I did this with. I did it just like I'm doing to y'all. And this is very abstract what I'm doing. So this was after they had played with those manipulatives for a long time, the kids. Okay. Because what I'm doing right now is really just making sense of what makes sense. I'm trying to get you to understand what makes sense. So 3.5 divided by 7/5. Will that be more than 3 1/2 or less than 3 1/2 for your answer? What do you think, Johnny?
Less,
And why?
I guess because of the first problem, how she explained it.
So, explain it.
That 7/5 is bigger than 1, right?
Right,
So
7/5 is bigger than 1.
It's going to be bigger than that 3, and you've got 3 of those 3s, so it should be smaller? Is that being explained?
So 7/5 is bigger than 1,
Right.
so it's not gonna go into the 3 whole times.
No, yes, that's what I'm trying to say. That's what I'm trying to say.
Right.
So then it should be smaller.
Smaller than
The 3.5.
the 3.5. Raise your hand if you agree. Raise your hand if you disagree. And everybody raised your hand that time, very good. Okay, so we can use a number line to illustrate what we just illustrated with those pattern blocks. So if we have 3 halves divided by 1/2, how many 1/2s are in 3 halves? 3. And on the number line, you would show it, I don't know why I have 2 number lines there. Where is the, yes, where is the 3 halves here? The red one?
1.5.
1.5, so which arrow?
The red one.
The red one? So the white arrow is the 1/2. So how many of these white arrows can you fit into that red arrow? 3. So the answer is 3. You did not have to invert and multiply, did you? Okay. So this one, 1/2 divided by 3 halves. This one is different. We have 1/2. Which arrow is